Although I learned OOP practices in my university programming courses, I recently came across Bob Martin's solid principles, and after studying up on them, I decided to make a program for each principle to not only demonstrate my understanding of the principles, but also because one of the best ways to learn something well is to teach it. Keep in mind, I've tried to make each program as simple as possible, so we're only going to deal with one principle at a time, and for simplicity's sake, I might leave out some important code here and there, like memory deallocation or deconstructors and header files. That being said, let's get to the content. ISP. Interface segregation principle is fairly straightforward. We don't want to inherit interfaces that aren't appropriate for the class. We don't want to inherit functions from interfaces that we don't use. Here's an example of code that violates ISP. Here we have a C creature interface, and we're going to pretend that our C creature interface has every possible behavior that a C creature can implement. Really, it only has 6 functions, but we'll just pretend it has much more than that. When we implement this interface in our crab class, we only use 4 of the functions. The bottom 2 are intentionally left blank because they're not applicable to crab behavior. We have a similar setup in the shark class. We only use half the functions, and the other half are overridden but are not implemented. In our main function, we create a shark and a crab instance, and we have them call their own intentionally implemented functions. However, they're also able to call their non-implemented functions. And this is problematic because someone editing this code might not know the specific behavior of a crab and might therefore code some undesired behavior into our main function, such as crabs using blowholes, even though they don't have blowholes. On a side note, we were able to leave the undesired functions blank in each class because they have a void return type. But if the functions weren't void, say this was of a different type, such as integer, then you can see how this would be really problematic whenever we need to put something in there, but we don't have an integer value for swim because crabs don't swim. Plus, look at all this code I have to write each time I create a new sea creature. So how do we go about complying to ISP? We make small but specific interfaces and implement them only when all of their functions are used. So here's our program after conforming to ISP. As you can see, our interfaces are much smaller and we have a lot more of them. But they're also much more specific. Going to the crab class, we can see that when the interface functions are implemented, we don't have to override the undesired functions because there are none. Crabs can breathe through their gills, they can crawl, and they can eat other sea creatures. Now, even though we have the same main function we had before, because our objects only inherit functions that they plan on using, our main function is no longer able to implement the undesired behavior. Lastly, since we designed our interfaces well, creating another sea creature is a breeze. In fact, I made a dolphin class this time, and this was all the code I had to write. I'd say most of conforming to ISP is done in the planning stage. You have to think about the other types of objects, or in this case sea creatures, that you might create later down the road, and build your initial program around the possibility that it will increase in size and vary in its future implementation.